All right, this is a short video on using sheets to calculate mean and standard deviations, and I'm using the data from the 2-6 class activity. So the central tendency that we're going to talk about is mean in this case. And by central tendency, we're just talking about where it's the center of the data, where the majority of the scores tend to group together, or the norm of the data set. And in this case, the mean is the arithmetic average. So the way that we calculate that is that we get the sum of all the values divided by the number of cases or the sample size. You can only calculate this for interval ratio, and you're pretty much always going to calculate it for interval ratio. It's the most common measurement for interval ratio variables. You will come across people who say that you can get a mean for ordinal. The problem is that ordinal variables, you don't have a proportional distance between your ranks. It's just rankings. It's not like it's the same distance from ranking 1 to ranking 2 and ranking 2 to ranking 3. So a mean isn't super meaningful. So there's not a lot you can do with that. So we're not going to do means for anything but interval ratio. This goes along with standard deviation, which we'll talk about next. So I'm going to go ahead and open up the sheets data so that you can see how to calculate this. All right, so here we are in the sheets for this activity. And you'll have access to this after you complete your calculations, so you can always click into my formulas. It is in the activity. So you can see here that I have the formulas for mean and standard deviation, just as a reference. And we have our participants, so participants 1 through 9. And we have each participant's score on the social media addiction scale, which is our scores, or our X. So for mean, and I can put this here just as a label. I'm going to center it. So I want to calculate the arithmetic average of social media addiction, which is the sum of X divided by N, which is the total number of scores. So I could calculate this the way that I would by hand. So I could do equals this value, so 7 plus 22 plus, and I could put all of those in there and then divide it by the total number of scores. I'm not going to do that because that's a very long, silly way to do it. Another way that you could do it is you could say, okay, I'm going to take the sum of all of these values. So I'm going to highlight all of them. You can also type in the address for each of the cells. So you can see column B, and that's row 4. So that's B4 through B12. And I could divide it by the sample size, which I know there's 9 participants. So I'm going to say by 9, which equals 19. I could also much more directly just go say equals average, select all of those, and it's going to do that calculation for me. And it's doing the suggested autofill. Don't worry about it. Just X out of it for now. I'm going to go ahead and this one, you can see it has 2 numbers after the decimal point. I want this one to do that as well. So I'm going to go up here to my increase decimal places and increase it 2 places. So you can see it gives you the same information, right? So you're going to have to calculate this on quizzes and exams, but you can always check your work while you're working on homework to make sure that you did it correctly by hand. So that's how you would calculate the mean. So I'm going to go ahead and go back and we're going to talk about standard deviation and then calculate that. Standard deviation tells us more about our data and about our distribution of our sample. So we know that the mean of social media addiction is 19, but we don't know if everybody has a 19. I mean, obviously we do because we just looked at the data, but we don't know what that spread is. We don't know how much variation there is. And so we can give that variation a number, and that's the standard deviation. It's one of the numbers we can give it. So the benefit of the standard deviation is that it tells us on average from the mean, which we now have, how much variation is there? And so we can say on average that people in our sample vary by however many social media addiction points. It is the most common measure of variation for interval ratio. So in journals, you'll always see that people report the mean and the standard deviation together. So think of them again as holding hands. And it's the square root of the variance, which is part of the formula. So we did talk about this in class, but as a reminder, our formula for standard deviation is that we are taking the sum of our squared deviations from the mean and dividing it by the sample size minus 1 for a sample. I have the population standard deviation formula here just so you can see the comparison, but you don't need to worry about that for now. So what we're looking at again is we're taking those deviations, which is the difference between each score and the mean. We're squaring each of those deviations for each score, and then we're getting the sum of those squares, dividing it by n minus 1, and then getting the square root of that to get our standard deviation. So as we discussed in lecture, you can't just get an average of the deviations. Even though that's conceptual definition, it doesn't work that way. If we tried to get the average of the deviations, if we tried to do that way, and we just said, okay, that's going to be our standard deviation, and this is not the standard deviation. I'm just, again, conceptually talking about this. So in your PowerPoint slides for class, I don't have that there. This would be the mean of the standard deviations, right? So if we were to try and do it this way, the issue that we come across is that we have all these different scores, and each of them is a deviation from the mean here. So these were plant growth in millimeter. So this plant grew 2 millimeters. This one grew 3, this one grew 4, etc. We got our deviations by taking x minus the mean for each of them. And so the deviation here is minus 2, minus 1, 1. This one was 0 because it's the same as the mean. So if we did that, we get the mean of that. We add all of those together, divided by the total number of scores, which is 5. It's always going to be 0. So you cannot calculate the standard deviation this way. So instead, we go through the process of squaring those deviations to get rid of the negatives, and then we have to unsquare it at the end. So I'm going to go ahead and take you over to Sheets, and we're going to demonstrate it there. Again, it's more to help you be able to check your work, but you're going to have to hand calculate throughout the class just for practice to really understand that concept. All right, here we go. So I'm back in the Sheets, back in our little workbook here. And again, we've already calculated our mean. And so as a reminder, this is our standard deviation formula. So I'm going to show you a couple different ways to calculate this. And I'm just going to move our mean. I'm going to use this formula. I'm going to grab it, move it up there. So our mean is 19. And I'll refer to it in our formula here. So let's delete these guys. Okay. So here we have our scores. So that's X. And so that's that right there, X minus M. So I'm going to put this as step 1. And you have the handout that I gave you, so you can always follow that. But this is our first step, is that we write out our scores for standard deviation. Now, our second step is that we need to take X minus M. So the idea here is that we're going to say equals whatever the X value is minus our mean, which is 19.00, right? And I can just refer to it right up there if I wanted to. So here I would say equals that score minus 19. And notice it's going to autofill it, and that is what I would like it to do. If you're not as comfortable with the autofill, then you can just X out of it. But I want to use that same formula for all of these. And so 7 minus 19 is negative 12. You can do this by hand. You're going to have to do this by hand on the exam, but I'm just demonstrating how this works again in Sheets. So if you hover over the bottom of there's a little circle there. So click into it, unclick, move away from your clicking for a moment, and then hover over the bottom right. When it turns to a black cross, you can click, hold, drag it down, and it's going to copy that formula down. So you can see that this is now, if you click on each one, This is B4 minus 19. This one is B5 minus 19, and that's B5. So it's just going through and calculating our deviations. This is our deviations. So I'm going to put in parentheses deviations, right? So now our step 3, we need to square those deviations. So we're right at this part where we've just gotten x minus m, and now we need to square it. So we need to do x minus m, and then I'm going to put squared. So again, I'm going to use my little equals, so it'll do the calculation for me. But I just want to take this number and I want to square it. So when you're in Sheets, you could refer back to it. So you could just say times and then click again here, and that will get you the squared value. You can see it's 144. But you can also use the notation. So you use the little, I'm blanking on the name of it, but the little hat caret thing, and then a 2, and that'll square it for you. And so I can click enter. And again, it's going to go ahead and suggest doing that all the way down. And I'm going to say yes. So I'm going to click this little autofill check mark. And so we have 3 times 3 is 9. 6 times 6 is 36. 1 times 1 is 1. And so we've now gotten rid of these negatives, right? So that's our next step. So we've now completed this part right here, x minus m squared. So our next step is that we need to sum it. So we're going to get the sum of our squares, which is also scientific notation SS. And that's in step 4. So for the sum of squares, and I can double click on the lines between them to make them the same size as the text that I have in there. So I want my sum of squares, and I want it to be the sum of all these values. So I'm going to say equals, you guessed it, sum. We're so creative in Sheets. So we're going to get the sum of all of those, or you could just add them together with your calculator if you're doing this by hand. Press enter. I do not want to do autofill because there's only one sum. So this number, this is the total of all of these. So we've now completed the top, the numerator of our fraction up here that's inside of our square root. Now we need to, step 5, we need to divide the sum of squares by n minus 1. So n minus 1 is our sample size minus 1. So we have 9 people minus 1 person is 8. So we're going to say equals that number, 552, wow, divided by 8 people. So that number right here, this is actually our variance. So equals variance. And people talk about variance. You might see it reported occasionally, but it's really not typically one that we report that often. So it's much more likely that we're going to, again, report standard deviation. So our last step, what we need to do is we're going to square root, not toot, the variance. And when we get the square root of the variance, I'll say equals SQRT. And the square root of the variance, I'm going to click on 69. So I'm just referencing the cell that we calculated the variance in. I'm going to say equals. And you can see that the value is already here, 8.31, rounding up. And it gives us that big number. This is our standard deviation. So this is the value that we were looking for. Now it has way too many decimals. If you calculated this by hand, your decimals might be off a little bit depending on rounding, but it should be pretty close to this. So I'm going to make my decimals smaller. So I'm going to reduce it by clicking this decrease decimal places button up here. There we go. And you can also double check it. So now that you know the long forever way to take to do this, the very simple way to do it is you say equals equals STDEV. You're going to use .s for sample, and that's right there. So I could click on it, or I could just put in my parentheses. So I'll put in my parentheses here. And then you just select your scores. And look at that, the number's the same. So those are the ways that we can calculate standard deviation in Sheets. So for now, for the first half of class, you are going to use your process. You're going to be calculating this on the exams, but you can check your work as you're practicing on this, and then we will be using Sheets later on in the semester. So that's all I have for you in this video. And again, you will have access to this so that you can see my formulas. You just won't be able to make edits. You'd have to make a copy of your own.